Great, cool, thank you. There's like a 5+ second latency. It's a little weird. And let me know if the music's too loud. Okay, so this one is chapter 19 of MBA, which is shellcode one. Third one's actually a PDF. What's the resolution right now? It should be like, really, fuck me. Okay.
Oh my gosh. Oh my gosh. Easy, easy. Hold it down, hold it down.
Is that any better?
Oh my gosh. Oh my gosh. Easy, easy. Hold it down, hold it down.
I think I can lower the resolution if I need to. Okay, let me check. Let me close the stream for a second.
Oh my gosh.
Okay, what about?
Oh my gosh. Easy, easy. Hold it down, hold it down.
Can you read in Ollie at all? Or is that too small also?
Oh my gosh. Easy, easy. Yes, you came massive. Yes, you came massive.
Yeah, that looks like shit. I changed, it was downscaling to 720. Is it any better? Oh, okay, solid. Okay, I'll start. I'm going to shrink the font here because this looks ugly to me. Alright, anyway, so this one's actually a PDF. It's a malware, and basically they just want you to figure out what it does. And I'm just in my XP VM, so don't think I'm stupid if I accidentally run it. Okay, so first thing usually, strings. A shit ton of them, so let's just find longer ones. Okay, that looks nothing too interesting. There you go. Here you can see some JavaScript, and right here a long one. Payload equals UN escape. Let's see if I Can open it into a hex editor. Should be pretty easy to see. So we got the PDF magic, and it's pretty obvious JavaScript here. Anyone else having trouble seeing the stream other than Cake Shop? I'm going to keep going unless anyone else has trouble. So anyway, let's just take a look at this. This is the unescape. Fuck. So one interesting thing about unescape for JavaScript is they basically have a non-standard implementation of it. So instead of just doing hex keys, it's actually little Indian 2-part ones. So I wrote something from when I actually did it right here in Python just to do it. So all it does is basically, if it's %u, it's a 2-byte version, and it just switches the order and decodes the hex, and then just builds up the byte string, joins it up here, and then writes it to a payload file. So let's run that. Computer's hanging. Oh, did you see that? Where is it? My antivirus is deleting my shellcode. How do you turn it off? There you go. Who needs antivirus? Alright, let's do that again. There you go. And now we have the shellcode. So MD5 shellcode, and it's BCE. Now going back to my VM, where is it? They actually provided it here somewhere, I think. So if you think I'm typing crappily, it's because outside of my VM I'm on one keyboard, and then inside of my VM I'm on like QWERTY. So I type retarded half the time. Okay. So anyways, MD5 sum, and they actually provide right here. And that's BC. So just to confirm that I extracted from the PDF the same one that they're providing, if we couldn't figure that out. So let's take a look at it in IDA. And I think I already had an IDB. Let's just delete it because it's cheating. There you go. Alright, let's take a look. C for code. Calls to here. Let's see what happens here. So I think this is actually data, but it might be decrypting itself. Thank you. So these are obviously strings. This looks like some loading loop. Let's figure out this one is first. But at the same time, one very nice thing they provided is the shellcode launcher. So it's right here. Okay, let's see what happens when we run it here. Alright, so I can go -I shellcode. Let's do that. Actually, I don't want to run it because that'll be bad. I'll just do it in here. -I. Alright, and restart. Alright. And I think I just accidentally ran the shellcode. Alright. Where's the jump? So this is just the loading. This actually isn't the shellcode at all yet. And somewhere it should call into it right here. So let's see if we make it that far. Nope, so I probably did the arguments wrong. Huh. Dash I. Oh, underscore sc.bin. Sorry, who else is having trouble on the stream? And sorry about the no 3D. Yeah, thanks, Chad. I figured that out. Alright. There you go, now we actually made it in. Weird, yeah, I use Chrome too. There we go, step in. Alright, so now we're actually at the shellcode. It's mapped at 350-100 versus 0 here, obviously. So if I want to simplify it, right here, I forget how I do this. Options, where is it? General, load base? No. Rebase program. So these are fine, if I remember correctly. There you go. Oh, no, that's fucked. File what? Okay, well I'm just gonna undo that because it actually worked fine for me at 0. Okay, anyway, so now we can follow through. And I usually like to run them kind of both at the same time. Alright, so what they're doing here, step, step, and call. But you'll see that immediately when they call, they're popping the return address off. Right, so that's putting this address here into ESI. The reason they're doing that, I've seen this a lot, is just because they don't actually care about the stack frame, but they just want a pointer to that shellcode, and they aren't sure where it's going to be loaded. Okay, anyway, so where are we? So pop ESI, ESI, follow and dump, 8E, and if you look here, 8E. So just, we have a pointer there. Oh, fuck. So this is kind of cheating because I already reversed some of these functions, but I'll show how it's done anyway. So get kernel 32. This one's pretty cool. That's this function right here. So if you look at it, what they do is they get FS30. That's what's it called? The PEB, process execution block. And from there, that's EAX. They get, is it on a loop? From there, they get offset C and 1C, and then I think they have to loop through. But anyways, what this does is it gets in the PEB and it finds the address of the first module loaded. And on Windows, that will always be kernel 32. So let's call that. All right. And yeah, if you want to follow through, same bullshit. So we'll return from there. And pretend I just named it now. Okay, so now it returned EAX, and basically they have a handle to that. Oh man, I wish I removed all this data. So anyways, this one let's step into. This one's pretty cool. What it does is it is provided a handle to a library, and then it's provided just some data. Oh, there's the return address. Sorry, right here, some data. I'm not going to go too much through it because I'm not going to waste my time. I never did, even when I didn't know what happened. But let's just return from it and see what it returns. Okay. So now EAX actually points to load library A. Okay. The reason it points to load library A is basically because it's provided a hash. It iterates over all of the functions that are exported from the provided library and hashes their name and then just returns the match. So if I actually put something here, and sorry, it stores it at EDI. So let's go there. Right here. So the next call here, you'll see it's 728 something. Oh no, sorry, it's this one. 16. So 16B3FE72. That's the next hash right here. And then on the next run, it will return create process A. And go back. So it actually runs this in a loop. Let's note what they're doing. All right, terminate process, get current process. Get temp path, get current directory, create file, get file size. So there's a whole bunch of them. In fact, I'm not going to write them all down. The reason being that Ollie will actually tell you the name when you have the pointer anyway. Anyways, if you look here, they're actually being saved into where the hash were. So this thing that was popped into ESI above, where was it? Right here, is actually just basically a table of hashes that became a table of funcs, and it loads 14 of them. Where am I? See, this is this is why you have to run into a VM, because I would have just run the shellcode accidentally. Step in. There you go. So load 14 functions is where we are. So here they're just dereferencing what's at EBX, and if you remember, EBX is actually that table that we can follow in the dump, and it's this address. So let's put a breakpoint here. Step into. EIP is load library A. So we know what that's doing, and the argument is shell32. If we go back, oh, I can just play. So called load library A, and it was provided shell32. Where do they come from? Oh, I'm not there yet. There you go. So CDs, when these are pushed on, that's literally just ASCII. So what they do is just move ESP into EAX. It's a simple way of getting a string inline. All right. So we already know what this function is. The difference is that instead of there's the hash as before, but instead of the address of kernel 32, it's provided the address of shell 32. So this is going to return shell execute A. And then this EBX is this base here. So I could have written them down. I was a little bit too lazy, but that's why Ollie or any good debugger is awesome. It just tells me the function here. So it's getting get file size. And you see here that there's a jump. So let's see what's happening here. Okay, so they're comparing it to EBX at 3C, which is another thing in this table. But right here it'll tell us. So it's 6CO2. So we can check what handles are open with the H button. And you can see that this thing is going to loop until it finds a match. And let's see if it ever finds a match. I'm going to put one here just in case. Yeah, so it's not going to find it. The reason is because it's looking for a specific file size. So what was it? 6CO2. So 2, that's 50,690. So I have a suspicion that I can check with the original PDF. Check the process properties rather, and it's the exact same size. So what this means is that the shellcode is basically trying to find the PDF itself in memory and get a handle to it. Cool thing about this thing is there's actually an option to load. Where is it? Oh, right here. You can go -R. So let's do that. All right. Lab 19-03 PDF. All right, and because this isn't loaded till after, all those breakpoints are going to be trashed, so you can just delete them all. All these ones. There we go. Step into. So now we know where we are. After the 14 functions are loaded, all these get populated, so that actually helps us out. Load shellcode A, and we were in get file size. So now let's pause here and check the handles. There should be the PDF loaded this time, which is cool. That's handle 1C. So let's go back to the code and see when this actually succeeds. There we go. So ESI is 1C. So that confirms that we're actually getting the handle for this PDF. Where is it? 1C. By the way, tell me if I'm going too fast, please, because I talk quickly, and I've already done this, so it's a lot faster than I would have on my first try. Anyway, so we have a handle to there. What do we need it for? Let's figure that out. All right, global alloc, allocating however many bytes this is. And it succeeds as expected. I think that's a failure jump. There we go. So now set file pointer on 1C at offset 106F. Let's go here to 106F. 106F. So it starts here. 711 DC. Okay, now here they're providing read file as a pointer into this function, so we'll have to see what's happening in here. All right, and let's do the same thing in IDA so I can get my graph view. This is a bit harder, and if I was smart I would have named all these offsets, but I already recognize this. This is the shell 32, which means this is load library A. This loop is where it loaded the 14 functions, and this is where they loaded the single one, I think. Or actually no, this is the compare, so this is actually the get file size. Okay. Okay. So what I'm looking for is where they're pushing. Is this it? I think this might be it. Where they're actually pushing. Where is it? Right here. Read file. Oh, never mind. So it's after like 4 pushes in a row. Let's see what that is. Push, 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 push. Right here. So this is read file. And then this function does something with it. So we know it is provided 2 things. So it's provided a function pointer. What else? It's provided 1C, so that's a handle. I have no idea what this is. I know this is the size, so this is the size. Oh, you know what? I bet this is. I bet you this is the buffer that came back from global alloc. So let's see. Global alloc, return it into A, save it into EBC minus C. Yeah, that's right. So this is, I said this is size? This is buff adder. So I mean, we probably don't have to reverse this that much. It's probably calling this func pointer on this handle, providing this address, and reading this much. Let's see func pointer. Yeah, they call it as expected, and they do it in a loop. So basically it just reads it in as many calls to read as we need. So let's confirm that. Let's get this address, follow it in the dump. Where are we? Oh, did I jump ahead? Oh, I must have jumped ahead, so this is going to be a lot. So I ran the, there you go, I got hacked. There you go. Smart graphs. And that's why you run it in a VM. Okay, step into. There we go. So, and then here's a load. I can push here and get the function so I know what I'm doing. Global free, global free. No, that can't be right. There you go. So get file size. So it was actually wrong at first. Right here is where we're interested. So I'm, oh, let's try to find the match. Okay, there you go. Now we have the match. It should be handle. It's still 1C. Again, that makes sense. Okay, anyway, so now we're in read file. The argument is here. Let's follow it in the dump. So it's here, and let's just see what happens. So 711 DC. If you look at the hex, it was 1060, 711 DC. So exactly as expected, it is reading some amount, 0xa000 bytes from the PDF. I could use like DD or just copy and paste from here to figure out what's happening here, but right now I don't care. Let's just figure out what it's doing with that data. So this is the same thing, MNO. Let's see if there's anything obvious in here. No, I don't think so. Okay, whatever. Right, get temp path. That returns whatever percent temp basically. Alright, here are more, it looks like ASCII, so let's see. Oh, so basically what happened is there's the temp, and it appended, it found the last null byte at the end, it decremented it, I think might have pointed past it, and then it just added foo.exe. So what I'm guessing is that big buffer is going to be written into it. And again, this is stupid dumb cheating because I already reversed the function, but I'll show you who did it. It's a really simple one. So right here, EAX is the string, 4A is 4A, whatever it's for. A 000 is the size, the buffer. What's EBX? I don't know what EBX is, but whatever. And let's step into this one. So this is 1EB, which should just be EB in here. Right here. Cool. So we know the arguments here. We can take a look quickly. So it is, I have no idea. Buff adder. Size. I don't know. Is that the file handle? I'm not sure. File name. And so it gets a file name, it calls something, calls something, calls something. We can take a look at that when we're there. So let's step through a bit. Okay, XOR AL DL. AL is, oh, I don't know what it is. Oh, we can just ignore it's a 7. But what's DL? DL is 4A. So that was the value that was pushed on. So obviously this is just a decrypt loop. If I can find the original buffer somewhere on the stack. Where was it? Oh, is that actually it? Okay. Right here. So if you look down at the bottom here, you'll see 1 byte at a time getting decrypted. And it looks like I was a byte ahead. So let's go here. 145. Right here. So I just wanted it better aligned. You see MZ, so you already know it's a PE. So basically, we can skip this loop. We know exactly what's happening. Okay, boom. Create file. So I think like what's important for people that kind of get bogged down in the details, you'll see that I'm kind of skipping through a lot of shit. It's because, at least on my first one, I don't care too much about the details. I care about what functions are being called, which are resolved automatically. I care about what arguments and just kind of track in my head what they have in different buffers. So anyway, create file A is called. it's provided foo.exe, simple. Okay, write file is called, it's provided probably the handle from there, and it's provided this PE. So clearly this is going to write a file. So if I run it, call write file. Oh, actually, you know what this is? I think this is the same function we already looked at. 23D. So it is. The one that did the read file before, it was provided a function pointer. The exact same file is done, but provided write file when you want to run the write it to a file. So we can skip it, but let's name it. What will I call it? IO file, or something like that. There you go. So again, I should be able to go, and there should be a foo.exe. Cool, just as expected. And then dump it here. Oh fuck, yeah, because it has the handle open, so we have to wait till here. There you go, let's try it again. There you go. So MZ, exactly as you expect. We can take a look at reversing this later. It's actually way bigger than I'd want, but see this, that's 0xa, obviously, the size of the alloc that was done earlier. So that actually makes a ton of sense. And we're done with that one. Okay, so we know this is decrypt and write, and it was just decrypted there, and it calls this IO file, providing write file instead of read file. So pretty straightforward so far. And then I think the rest is probably pretty simple. So a whole bunch of things to create process. They're actually creating I think a little struct block on the stack, and then just providing the address there and create process. So yes, exactly. Create process. This is the annoying binary. I imagine if we were to reverse engineer this guy, it doesn't do much more than message box. Okay. Fuck. Okay. Yep, it's annoying. There you go. Now let's see what else happens here. Okay, it frees this one, which is the MZ. So basically they just wrote foo.exe to the buffer. Now they don't need it anymore. Global alloc looks like they're probably going to do something similar. So let's try to skip and save some time here. So we know there's a global alloc, and then a set file pointer, then a read file. Global alloc, set file pointer, and read file. Easy enough. But we do care about the file name, and we do care about the file pointer, because that will tell us in here what it is. So let's do that. So there's allocation, file pointer is at bo6f. bo6f, right here. I'm guessing that there's going to be a decrypt. So anyways, it reads out some amount, and it is done right here. Follow dump, and call it. There you go. So 6F1B08. What was the address? Oh, maybe I got the offset wrong back here. B06F. Oh, this is B6. B06F. So right here, 6F1B08, 6F1B08. So just confirming that we could extract it right from the file if we wanted to. Okay, and then the IO file, so it's going to read it out. Decrypt and write, and it actually looks like it uses the same XOR key. So I have this buffer open. Just keep your eye right here. Boom, decrypted. And then %PDF. So it looks like it actually drops a PDF this time. Maybe it's another shellcode. I don't know. I hope not. Let's continue through. So this time they are calling it. I probably skipped through at some point, but there would have been more ASCII stuff to create a new file name. If you look here, though, again, it doesn't really matter because I can just see on the call. Looks like it's creating bar.pdf. So let's create it. And then it's going to write the buffer to it, and it's going to close the handle. Okay, so let's check here. Bar. And see what it is. It's a PDF. I don't know how to parse PDFs. Is there anything cool in here? I don't think so. Like, I don't see any JavaScript or anything. Okay, let's see what happens. Oh, shit. Okay, cool. So they're going to shell execute something. And this looks like more ASCII. So into what's that, EAX? It's the word open. Okay, that's simple enough. They're going to run open. Right here, they're just going to try to open the PDF. So if that could just open it in the default viewer, I think. One cool thing about my setup is I don't have a viewer installed. So if this is more malware, even me messing up wouldn't have done anything. So I'm not sure what that is, if it's a PID or something, but we could check that if we needed to. H instance. Greater than 32. And it returned 1F, so that's less than 32, which means it fails. That makes sense. Return, and I'm not going to decode these. It was an error, I don't care. And then this is simple, just get terminate process. Done. Okay, so I think pretty much understand it. We can quickly take a look at, so let's close this. And let's look at what it dropped. So that is, we can look at, well, let's just figure out what this PDF is. Oh, yeah, exactly. Okay, next. Let's look at foo. I know what happens when I run it. I know that pop-up happens. I just don't know if anything more malicious. It was actually like 40 kilobytes or something like that. So, what just happened? Okay. So always check imports. I didn't check the imports for the shellcode just because it doesn't have imports, obviously. Okay. Anyway, so let's look at the imports. There's actually a shit ton. So that sucks. I hope it's not anything too interesting. But here's the main function. This is an annoying program. It builds a string. Let's see the string right here because it has a process ID and process name. Okay, let's go back. And it obviously does something in a loop. Message box sleep. Press H for decimal, which makes sense, and 1,000 milliseconds. So literally, it's just going to do this in a loop. It looks like the other imports are useless, unless I'm missing something, which could very well happen because win main is actually called from here. This looks like normal Visual C, C++, whatever, boilerplate, but it's not uncommon for people to sneak things in here. Yeah, I don't know though. I think this looks pretty normal. So let's just assume that that second malware actually doesn't do anything other than annoy you. So cool, that actually took less time than I thought. I kind of wish I deleted the function names, but whatever, it was fun. Yeah, let me know if you guys have any questions. I'm behind on the Slack chat, so give me a second. Oh, okay, yeah, cool. So I'm gonna go offline. I'll probably do more. I'll probably do a harder one. I was worried this would take too long, but we did in like 35 minutes. So, all right. So thank you very much, guys. Later, said MJ.
You know what's better than AMP Energy?